Hello, I'm Sophie Rovner from the American Chemical Society. Welcome to this news briefing from the ACS Fall 2020 Virtual Meeting and Expo. We're joined today by Dr. Lisa Dean from the USDA Agricultural Research Service. She's studying how to make more healthful milk chocolate by adding peanut and coffee waste. Dr. Dean.
Hello, I'm Lisa Dean. I work for the USDA Agricultural Research Service. I'm part of the Food Science and Market Quality and Handling Research Unit, which is dedicated to research on a variety of commodities. My particular commodity is peanuts. So to discuss the project, we have a number of peanut processors around the US and even around the world that generate hundreds of thousands of tons of peanut skins as a waste material every year, especially the peanut butter industry, because the peanuts are roasted and then the skins are removed because they have this very bitter flavor, and they cause the peanut butter to be to look kind of darker than people want it to look if they're left on. So we have been working for a number of years to try and come up with some way to utilize that material. And one of the things that we have found, and a number of researchers have reported on this over the past 15 years especially, is that these peanut skins are very high in phenolic compounds. And that's something that we should probably try to utilize and not throw away. So we came up with a scheme essentially to remove the phenolics from the peanut skins, and that leaves the skin material, the fiber and the protein that is now debittered, and that can go to animal feed. And the animals can tolerate it much better than trying to eat intact peanut skins. So we captured this material and tried to find an application for it. So we all have, from the slide here, you can see a discussion about dark chocolate and human health. And cocoa is a source of these compounds known as the flavanols, which are essentially polyphenols that have had positive impacts on human health. They are known to mitigate free radical damage, which is responsible for a number of issues in the human body, such as aging, cancer, etc. And they're also vasodilators. So consumption of dark chocolate with these compounds intact is proven to have an effect on lowering blood pressure. And they also play a role in glycemic control, in reducing your glycemic response to eating foods. So in the next slide, there's a number of food waste materials that also contain these compounds. Peanut skins is what we focused on. We extracted them, encapsulated the phenolics in maltodextrin, which is a carbohydrate that comes from corn that's similar to sugar, but it's not sweet. But it can encapsulate the polyphenols and mitigate the bitterness of the flavor. So when we were looking for applications, since it is peanut, the amino acid profiles or the protein profiles are very different from peanuts kernels, but it's still peanuts. So we're very careful about applying the material because of the high allergenicity of peanut. About 2% of our population is actually, sensitive to peanut, and some people is so sensitive that they go into anaphylactic shock and it's deadly. So we wanted to be very careful not to use the material, anything that consumers would not associate with peanut. So that's why one of the reasons why we picked chocolate, because of the top 10 popular candy bars in America, 5 of them contain peanuts. And the number one candy that Americans buy is M&M peanuts. So Americans like peanuts and they like chocolate. So put them together and they'll buy it. So that's why we chose chocolate as one of the things that we use this ingredient with. And but a number of waste materials, like I've listed here, also contain these compounds. And if they could be recovered out of them, they would be a source of this similar type of functional food ingredient. So we incorporated it into milk chocolate and did consumer testing to see did consumers object to it. That was our main goal. And what we found, I think is in the next slide. Yes. What we found was we could incorporate this material into milk chocolate. We went as high as 8% by weight. And so we incorporated it in, and we asked the consumers, we did what's called a threshold test. We would give them 3 pieces of chocolate, 1 that contained the ingredient and 2 that did not. And we started at at 0 amount, and then we gradually increased the amount that was in the dosed piece until the consumer said to us, something's different. We didn't ask them, do you like it? Do you not like it? We just asked them, can you tell? Is something different? And we could get all the way up to past 2.5% before most of our test subjects said, something's different about this. So when we measured the antioxidant activity using a chemical assay, which is what some of the products of this type are using to judge bioactivity, does it quench free radicals is what the test is evaluating. We found that the amount that the consumers were saying, I see something different, was above that of the bioactivity of dark chocolate itself. So that said to us, here's a way to fortify milk chocolate. Consumers won't notice, but they'll get the effect from these compounds that they would get as if they were eating dark chocolate. So that's the gist of what we did.
At this point, we'd like to ask if there are any questions from viewers. If so, please state your name and affiliation in the chat window when you type in your question. So I'll start with this question. Is there actual clinical evidence that dark chocolate provides health benefits?
Yes, there is. I'm not able to quote to you the study, but of the types of these compounds that have been studied clinically, they've been studied in chocolate more than any other food, except for maybe tea. Tea has been highly studied. And they have proven, especially the vasodilation, which lowers the blood pressure, and the glycemic control. And we actually did a little study with using this ingredient. We coated peanuts with, made a candy coating for peanuts and added this ingredient. And then we evaluated the glycemic response of the test subjects eating the peanuts. And we actually saw a decrease in the glycemic spike when they ate the peanuts with ingredient added to it. So that kind of proves, yeah, that really does work. But there's a lot more research with chocolate, tremendous amount.
So why does milk chocolate contain lower amounts of phenolics than dark chocolate?
Well, the phenolics are in the cocoa itself, which is the main ingredient in chocolate. But of course, dark chocolate contains much more cocoa. And I've seen bars up to 97% cocoa. And they're very brittle. Of course, they're very dark in color, and they're extremely bitter. I tried one of them, and to me, it tasted more like tobacco than chocolate.
Oh, wow. So
Yeah.
what do you know what kind of percent roughly cocoa would be in milk chocolate?
I think it's around 30%. I'm not really sure. I'm not a chocolate expert, so.
Mm-hmm.
But milk chocolate, of course, contains more cocoa fat and sugar, more sugar. And because of the cocoa fat amount, it has a different melting capacity. It melts in your mouth, around body temperatures when it melts. So it feels really nice when you eat chocolate. Whereas dark chocolate, especially the high cocoa ones, is very brittle and kind of waxy almost. And you really have to chew it down to consume it, as opposed to just letting it melt in your mouth like milk chocolate.
Are the phenolic compounds in peanut skins the same as in dark chocolate?
Yes, it contains the same basic compounds, but they're more polymerized. And that will probably play a role in intestinal absorption. The absorption may not be as high, and that's something that has to be evaluated. And people are currently working on that.
And so are you saying they're more polymerized?
In the peanut skins than in cocoa. Because one of the things that's done with cocoa, I think, is it's processed in a way that breaks them into monomers more than in just extracting it out of peanut skins.
Do you think that added phenolics from peanut skins could help give milk chocolate a longer shelf life?
It's a possibility because they are antioxidants, and one of the goals of an antioxidant is to retard rancidity in oils. And that's actually something that we are currently doing shelf life studies on in peanut butter. If we were to add this material to peanut butter, which of course is 50% oil, and it's a rather polyunsaturated oil, we're looking to see, does that give the peanut butter a longer shelf life by retarding that rancidity. Cocoa fat is much more saturated, so I don't think rancidity is as much a problem with chocolate so much as just straight up staleness, and that phenomenon that they call bloom, which is where the cocoa fat oozes out onto the surface and it looks white like it's moldy, but it's really not. It's just the cocoa fat's on the outside. So I kind of think probably it won't have any effect on that. And of course, since the cocoa fat levels in the dark chocolate are so low, I don't think bloom is as much of a problem with them.
All right, thank you. Do you have a sense of whether the cost of antioxidant fortified milk chocolate, how that would compare with that of dark chocolate?
It should be cheaper. I mean, essentially you're taking something that's going to go either to a landfill or, to animal feed, where essentially processing plants, they don't sell it, they give it away. And if you could economically extract it, it would be cheaper than using cocoa. I mean, cocoa is rather expensive, and there's a lot of, discussion about sustainability of cocoa around the world, what it takes to grow, because it has to grow in a tropical region. Peanuts, of course, can grow all the way up, especially in the US, as far as there's actually peanut farms in Missouri now, can come all the way up into, Tidewater, Virginia is where the majority of the, where there are a lot of peanut processing plants and people growing Virginia type peanuts, which are the ballparks. So, and in extracting it, we used just water and ethanol. And so it would be food grade. I mean, there's a number of ways to extract it. If you look in the literature, people are using methanol, acetone, and all kinds of polar solvents. But we used ethanol because we wanted it to be food grade, and we recovered that ethanol and could reuse it. So the solvent costs, can be reduced. And of course, peanuts is a very sustainable crop. It uses a lot less water. It does need water, but it's a lot less than tree nuts.
Have you tried adding phenolic compounds from coffee grounds, discarded tea leaves, and other food scraps to milk chocolate? If so, what waste product seems to be the best source?
Right now, we're experimenting with coffee grounds, but we're not so much extracting that as kind of using it as a flour substitute. Collecting it from, I think, I'm working with someone from NC State Food Science Department on this, and collecting it, I think, from Starbucks, retail outlets, and because Starbucks is very interested in recycling and sustainability, and so we're actually just using it as a flour substitute to make like brownies. And
so coffee grounds are edible then?
Yes, it's just it's bitter. That's the main problem. So, if you can mix it with other things, extend it, encapsulate it, anything to keep that bitterness away from your tongue, you can use these materials. It's just reclaiming them. Some things are easy to reclaim, like peanut skins, because they're processed. Other things like tea, you go around to coffee shops and break open the tea bags, or whatever. It might be much more difficult to reclaim them as opposed to composting them. Many places, including NC State, have these big composting programs now for food waste, and these are great. They collect anything and everything, coffee grounds, pizza boxes, whatever, and they have a giant composter that supposedly you could throw, like a whole deer into if you needed to, and compost that and then take it to the farms and use it to enrich the soil. So that's another way to go with these agricultural wastes. But if we could get something more value added and it's, easy to get to, as opposed to, trying to collect it small bits here and there, I think it has a better chance of being commercialized.
Did you have to alter the recipe of the milk chocolate other than adding the phenolic compounds?
No, we purchased the chocolate, the enrobing chocolate that they use to make candy. We purchased that and melted it down, added our material, and then poured it into molds to cast our chocolate squares. It was just a mix-in. It wasn't really, we didn't start from scratch and make chocolate.
And then were the properties of the chocolate in terms of melting temperature and flow similar to regular milk chocolate?
Yes. I mean, the melting temperature didn't change. The color didn't change. So, like I said, unless you knew it was there, you couldn't tell. And we went up to 8% with it without any problems in texture or appearance.
Mhm. All right. Do you plan to do further testing to make sure that the new chocolate doesn't contain peanut allergens?
I probably won't. Like I said, my commodity is peanuts. I work on, other things, mostly on peanut flavor projects, peanut nutrition projects. What I'm hoping is, someone will notice, these talks or papers or whatever, and be willing to take the technology away from me, let me transfer the technology to them to make a product, and they would be the ones that would investigate the allergenicity further. Like I said, we have looked at the proteins that are there, and structurally, they're not anything like peanut protein. They're mostly proline, which is the bitterness that sticks to your tongue. It's the proline that's bonded to your tongue to make the bitter flavor. And we have done ELISA testing, and it's been negative, but again, it's peanut allergy is so dangerous that, it's not worth the risk.
So last question here. Have you seen any interest from chocolate manufacturers?
Actually, Mars owns the patent on nut skin use in foods. So it can be commercialized if someone works with Mars on either licensing the patents, or if Mars were to do it themselves. But actually, the interest that I've gotten is from people making gummies. There's a lot of gummy products out there that are contain different bioactive materials, and are using a lot of food waste, like peels from vegetables and things like that. And those are the people that have asked me about, technology transfer of this ingredient material. So maybe if we made a peanut shaped gummy, that might work.
I love it. All right. Well, thank you very much. The archived version of this session will soon be posted at www.acs.org/fall 2020 press conferences. Please join us for our next press conference at noon today on pothole repair made eco-friendly using grit from wastewater treatment. Thank you.